So what we've discussed so far was really applied to wired networks. And as some of you know well, a wired network, a wire link, is very different from a wireless link. And in particular, the big difference is a wireless link will experience loss in transmission that are mostly not happening on wires. I mean, the chances of loss in transmission on wires are like 10 to the -5 or something. In wireless, they are happening all the time, and even on license bands, you will observe loss due to passing object that will occupy the Fresnel zone and reduce the link budget, or self-formed interferences, like you have echo of your own transmission, so we call that multipass fading, which will also alter the transmission that you have. So a single link will never give you reliable and available transmission. There will always be times where it's not there. And what we claim at the IETF is that layer 3 can help there by actually optimizing the use of not just one radio link, but multiple radio links of different technologies in such a fashion that if one technology or one channel, one band is not good for you at one point of time, then by using maybe another band or another technology, different antennas, etc., you may be able to send your packets. And so by duplicating, if needed, the transmissions over multiple paths and doing that intelligently because you care about the spectrum and you care about your battery, then we can actually achieve, as controlled by the upper layer, by layer 3, transmissions over multiple radio technologies. So we formed this raw working group, just formed at the IETF to try to solve that particular problem. So I'm giving you links here, and you will see the preparation meetings that we call Bird of a Feather, BOF, and all the slides, etc. They're all available on the links that I have here. And like I said, for the virtual IETF 17, which just happened, RAW met for the first time. We have a charter, I give the link, and the charter tells us that we'll provide like use cases for which this raw work is necessary, the requirement and protocols, what we need to achieve, and provide a framework and possibly some architectural work to do that. We will be focusing on some technologies. One of them is LDAX, that's a new FDA-made tech for avionics, how you air-to-ground and I believe air-to-air as well, I'm not sure. 5G, obviously, everybody knows 4G, 5G. Wi-Fi 6, 7, meaning AX and BE, which are BE is now the new effort at the IEEE. And 6TiSH, which is an IETF working group that focused on doing IPv6 over time-slotted channel hopping, so a deterministic MAC layer technology on which we care to provide deterministic and stochastic IPv6 flows. And 6TiSH has focused on how you can use this deterministic MAC, that is TSCH, time-slotted channel hopping, so as to do non-deterministic best effort IP traffic. And so we need to go back to the efforts on deterministic from which we actually inherit, but we also need to consider the fact that wireless is a different medium. On the one hand, we saw earlier that deterministic networking can rely on scheduling to provide reliable delivery within bounded latency, because effectively scheduling eliminates congestion loss. You guarantee that there won't be a saturation of your outgoing queue, so you won't have to discard the packets. You can guarantee the latency, and you mostly do that because you know that at a given point of time there will be at most one deterministic packet to be sent on one outgoing interface. And as we know on Ethernet, full duplex, you control your outgoing interface. So if you know that you have only one packet to be sent on this interface, then there will never be a collision between two deterministic packets. You can always send it at the scheduled time. And the third thing that we do in deterministic networking is to rely on replication and elimination. For instance, at the ingress of the network, you make two copies over two non-congruent paths, and you try to avoid shared risk link groups, SRLGs, so you're sure that even if one of the paths breaks, then the other path will still allow the packet to go through. And at the egress, you basically perform what we call elimination, which is remove the redundant packet. And that's exactly what .NET calls pre-auth, packet replication, elimination, and reordering function at the egress. Now, on wireless, we can benefit from the exact same benefits actually of scheduling. We can provide the high delivery ratio using redundancy that can allow us to eliminate collisions, because we can schedule on different channels. So even if we have two non-concurrent paths, we also need to eliminate the effects between those two paths. They can be a shared risk link group if they operate on the same channel at the same time. So we can actually schedule to ensure that different transmissions which could happen at the same time happen on non-overlapping channels. We can guarantee the high ratio of critical flows, meaning that on a .NET network you can reach like 60–70% of critical flows, compared to traditional stochastic network where this number is like 15% or something. And we can have bounded latency because we can follow the progress of a packet on the network. At the same time, we have additional unexpected benefits, if you like, to scheduling. The first benefit is that we can eliminate the gaps, the silence, which is inherent to CSMA-CA operation. For instance, on Wi-Fi, you've got this concept of an interframe space, which is a silent space where a random number is injected to try to avoid collisions. And if the collision still happens, then you have an exponential backoff, which still introduces more delay in accessing the channel, and again creates stochastic effects. Those gaps, those silent zones, can be avoided if we have a scheduled transmission and only one at each point of time for each spectrum resource. The second thing that is quite critical for IoT devices, for instance, is the fact that, as you know, on an IoT wireless device, the radio will be the most important budget for the consumption of the battery. So if you can avoid idle listening, where you listen to see if somebody is talking to you, and you only wake up at the time of a transmission to transmit or receive, and then you save your battery all the rest of the time. And if you really want to have a long duration of your battery and be battery operated for years, then you need to schedule your transmissions. There is no magic. The way we actually do envision this reliable and reliable wireless cannot be exactly the same thing as we do on wire. For instance, you don't own the spectrum. You can't transmit at the time you like, and just by having controlling your own transmission, you know exactly who is going to content to the network. The medium is shared. There are all sorts of interference. Some of them can be eliminated by having a license band, and some of them not. We have to combat many forms, many reasons why a packet can be lost. I mean, that can be interference, that can be passing objects, that can be many sources. And the only way to combat unknown, unpredictable forms of collisions is by using all the possible forms of redundancy, of diversity. We need to use diverse technologies. If we need to use diverse spectrum, we need to use diverse path. So that's spatial diversity, frequency diversity, etc. We need to leverage all possible forms of diversity. So actually on wireless, you've got more forms of diversity than you have on wire. In particular, in this new term Pareo that we formed, we include the time diversity, where we do retries on one hop. We also use the capability to do overhearing, where C can actually hear the transmission from A to B. Diversity is the key thing. And so for RAW, we'll be looking at pretty much two use cases. One of them is I have a first hop which can be wireless, and then I can leverage possibly different forms of radio access. And the other use case that I can look at is I've got this wireless mesh, and I want to establish, say, a control loop inside the mesh between point A and point B, and then I have to react very fast to changes in my radio connectivity, like a linking flap for a split second. I have to reroute my traffic or change the way I use diversity so as to guarantee the SLA that I have for this flow. That's what RAW is looking at.